Okay, tampil suara di JBWTM. Muhammad Azimi. Kota Baru Kelantan. Syariah Eman. Masuk macam ni. Okay. Okay, so Assalamualaikum, selamat pagi. Okay, saya dah letakkan QR code juga untuk attendant. Please don't forget to scan. Okay, hari ni kita nak go through few more example dan exercises. Saya tengok apa lagi ni. Chapter 3, fatigue failure. Okay, kita akan continue with apa ni. Okay. Exercises. Oh, tak ada masuk. Okay, setakat ni apa ada soalan? Abdul Harzan, Abdul Muaz, ada apa-apa nak tanya tak sebelum kita bersambung lah? Kita sambung sikit lagi example dan exercises.
Oh, sekarang tak ada sir.
Ya, boleh faham ke setakat ni?
Oh, faham sir.
Senang je. Okay, so tak apa. Okay, ini kita akan tengok balik. Ini exercise. Okay, saya akan share, sorry tak share screen pula. Masuk ni. Amirul Zainal Muhammad Amin. Arzan Haikal. Okay, saya nak share screen. Okay, kalau nanti tolong beritahu kan kalau ada kawan yang nak masuk, kadang saya apa ni, tak perasan. Okay, let me know please. Tidak, korang tu tunggu lah kat luar. Okay, so this is on still kita dengan static failure sebenarnya. Okay, we started with FBD. Kemudian okay, we have this question before. Okay, soalan, this is exercise lah. Okay, so ada structure, ada AB with the rod AB connected BC connected to CD. Okay, kemudian ada PX. Okay, we have the PX at the angle theta. Okay, kita dah tengok dah itu FBD dia. Cuma we'll actually ambil the same example to calculate dia punya safety factor dan DET theory using teori apa ni, static failure theory. Okay, so okay tak macam ni, saya tengok mana yang sesuai ni. Okay, so this is the structure tu. Okay, so the diagram of the above PX supported by a structure of connected rod AB, BC and CD. Okay, so all this problem, okay, normally they will also inform you or give you the information, okay, about the material. Okay, so in this problem, material is IC AISI 1020 HR rod. Okay, the rod is fixed to the wall. The force is 200 Newton px. Angle theta is 30 degree. Diameter D1 given 15 mm, D2 12 mm. Find the safety factor. Okay, safety factor using maximum shear stress T and distortion energy theory to determine the most critical part of the structure. Okay, so in the design process, okay, so please remember what is need to be find is to find the critical point so that we can calculate dia punya safety factor. Okay, daripada critical point tu we are going to identify what is the maximum loading dia. Okay, and then maximum loading will be used, okay, to find or to get the safety factor. Okay, so the safety factor, once you get the safety factor, okay, then you are you punya component ataupun you punya part, okay, is ada dia punya safety lah kan. So what are the loading, okay, the range of the loading that is allowed for your structure or for your component. Okay, so it will involve dia punya dia punya material, then it will involve the size, the dimension of your component. Okay, so all this, okay, will be considered. It will be considered and put into calculation. Okay, and then the forces lah. Okay, what are the common loading? Okay, ataupun the loading for the object structure. Okay, so okay, if the length AB is increased 1250, okay, if the length AB is increased 1250, will the safety factor A increase Y? Okay, kemudian okay. Okay, tengok dia punya ni. Okay, we engineering judgment solution. Okay, we will go through the solution. Okay, if the diameter of the structure is the same, point A is the most critical. Okay, point A is the most critical. Because the position of A will result in the largest bending load. Okay, sebab dia punya distance is the jauh sekali lah. Okay, if the whole rod having the same diameter, okay, but now tak kan, it's different diameter. AB is 15 mm, D2 is 12 mm, okay, so you need to you have to check, kena check. Okay, however point B is another point to be considered because it has smaller diameter that may result in higher stress. Therefore, point A and point B are the candidate of the most critical point, and the stresses of both point must be calculated. Okay, so kita kena check point A and point B, and then dapatkan which one is the having maximum loading. Okay. Okay, sekejap. Mana saya punya ni? Aduh. Sorry. Okay, sabar. Sini pula ni. Sorry sekejap. Mana ni saya dah snap lah. Okay, so kita nak tengok apa tadi? Lupa. Jawapan solution ni for that. Okay, this is dia punya loading for point A. Okay. Okay, ini ialah at point A, okay, tengok, you will have these three reactions. Okay, three reaction at point A. Satu is P to 200 Newton. Okay, the P itu is the one that counter PX. Okay, PX positive X direction for example. Okay, so P tu dekat support A, point A. Okay, is pointing to a negative X. Okay, to 200 Newton for P. Kemudian P2, M1 is 200 times 75 cos 30. Ini ada mistake sikit. It should be 75. Okay. Okay, dekat PX tu, from that PX is going to ada mana pula point yang saya dah snap dah tapi apa jadi. Okay, so okay, this is the three reaction support. Okay, M1, the 200 Newton, okay, PX tu kali dengan 75, should be 75 sin 30, 75 sin 30 actually. Okay, dia punya distance is going to PX tu 75 sin theta. Okay, then for M2 is 200 100 tambah 75 cos theta. Value tu betul, cuma sin dengan 3 cos tu ada silap sikit. Okay, so ini yang kita dah tengok juga itu. Okay, so this is the true support reaction. Okay, kemudian okay, okay, we need to get the okay kat point A ni, okay, for point A. So we need to get the total moment. So ada dua moment tadi, M1 dan M2. So get the total moment. M total is M1 square plus M2 square root. Okay. So dapat that M total, then we proceed. Okay, we proceed with the sigma apa ni? Sigma average. This is sigma average. This is due to the P to value macam axial loading tu. So it's going to be P over A. P is 200. A is pi d square over 4. Okay, diameter untuk shaft AB tu is 15 mm. So dapatlah okay, sigma average for apa ni load axial tu lah kan, axial loading tu is 1.132 megapascal. Okay, kemudian from moment tu bending moment pula, okay, using the equation sigma bending, sigma B tu, okay, kita dapat M total 3.383 tu, use that M, okay, using the formula 32M over pi d cube. So calculate for sigma bending, you get your sigma bending 102.1 megapascal. Lagi masuk ke? Okay, selamat datang Fairul Izwan. Okay, boleh yang baru masuk boleh share nama dan lokasi di message. Okay, so kena pakai, so mana tak dapatkan sigma bending, sigma axial loading dia. Okay, kemudian dapatkan stresses at the element. Okay, stresses at the element sigma x. Sigma x. Okay, untuk DET dan MSST ni kan kita kena apply ni, yang ni apa ni, sigma element ni yang apa, stress transformation equation. Okay, yang mau tu. Okay, so sigma x will be sigma average, sigma axial tu tambah sigma bending. Okay, so that is sigma x. Okay, sigma x. So total is 103.2. 103.2. Okay, so 103.2 megapascal. Kemudian for point A ni there is no torsion. Tak ada torsion. Okay, so 0, tau xy is 0. Okay, kemudian ini masuk DET tu, distortion energy theory. Okay, distortion energy theory, cari sigma prime. Sigma prime tu, sigma prime is equal to sigma x square plus 3 tau xy square root. So the same, get 103.2 megapascal. Masuk Luqman Hakim. Okay. Syazwan, Ahmad Syazwan. Okay tak Syazwan? Okay, dapat sigma prime tu kena pakai SY pula, cari SY. Okay, untuk DET kita akan guna SY. DET dan MSST tu dua-dua tu is related to ductile material. Ductile material ni dia akan bend ataupun dia akan yield dulu. Kan, sebab dia tak brittle. Brittle tu yang pecah terus, tak ada nak yield lagi. Okay, for ductile material and apa ni, for DET distortion energy theory and MSST maximum shear stress theory ni, okay, we will apply SY value. SY value ni is the material property, okay, the yield strength. Okay, yield strength tu biasa kat atas, kat graph SN curve tu dia naik dekat atas, paling atas lah biasanya. Okay, that point, kemudian dia curve down, bend, turun balik, kemudian baru fracture. Okay, so SY for 1020 IC 1020 HR from table C2 appendix C is 290. Okay, so just need to get that value 290 kalau tak diberi lagi. Okay, so SY 290 megapascal and then use the equation, formula for safety factor. And for DET is equal to SY divided by sigma prime. Okay, sigma prime is 103. Kemudian that SY is 290 megapascal, you get your safety factor 2.8. 2.8 safety factor. Okay, that is for DET method. Okay, kemudian MSST method. Okay, MSST, shear stress, shear. Okay, so sama juga, you have to find apa ni, principal stresses, sigma 1, sigma 2. Okay, so equation, this is the equation standard sigma x over 2. Okay, patutnya sigma x plus sigma y tak ada. Okay, so sigma x over 2 plus minus square root of sigma x over 2 square plus tau xy square. Okay, so sigma A yang plus ambil tambah, sigma B ambil tolak. Okay, so that is the way. Okay, so get your sigma A. So sigma A is 102.3 megapascal. 102.3 megapascal. Okay, sigma B is 0. So sigma A tu is your sigma 1. Sigma 1 is the principal stress. Okay, principal stress sigma 1, convert the principal stress sigma 2 equal to sigma 3 equal to 0. Okay, so okay, tak apa. Okay, and then for safety factor according to MSST is SY over sigma 1 minus sigma 2, sigma 3, sigma 2 or sigma 3 lah, sigma 3. Okay, sigma 3. So 290 divide by sigma 1 is 102. Okay, yang bawah tu ada mistake sikit. Okay, it's not 103, 102.3 terbalik. Okay, but the value will be similar 2.8 juga, 2.8 something. Okay, so this is the method, DET method, MST method. Boleh? Hakim Rafi, okey ke? Okey kan?
Ya je kot.
Okey kot. Tak ada masalah. Okay, so that is point B, point A. Kemudian tengok point B. What is point B? Okay, point B pula. Okay, kita dah tengok point B punya. Okay, point B. Nampak lah. Point B punya. Okay, point B punya arrangement. Snap je tadi. Tak nampak. Okay lah. Okay, point B punya. Okay, ni sama point B. So point B punya pun ada 3 reaction at point B. Okay. So tengok ada M, ada V. Okay, that one consider V yang 200 Newton tu now. Okay, so kemudian ada T. T for torsion. Okay, so ada moment, torsion dan shear. V itu shear force lah. Okay, consider as B. So untuk okay, so moment ada satu je, so M is going to be that M. Okay, gunakan equation tu. Okay, so 32M over pi d cube. Okay, you get your sigma X. Sigma apa tu? Sigma X. Okay, 194.5 megapascal. Okay, kemudian torsion punya equation. Okay, torsion ada torsion, so we have to use the torsion equation. Torsion is 16T tu. 16T over pi d cube. 16T over pi d cube. So 22.1 megapascal. Okay, so only considering these two. The V tu tak ada, tak guna. Okay, it is okay, only that two. Okay, and then apa ni, equivalent stress. Okay, for equivalent stress, apply equivalent stress. Okay, equivalent stress guna yang apa ni, sigma prime equation. Sigma prime equal to sigma x square. Sigma x square and sigma x square plus 3 tau square. 3 tau square. Okay, so sigma x value dah ada. Tau xy pun ada. Okay, so just get your sigma prime. Sigma prime is 198.2 megapascal. Okay, so dapat sigma prime, then okay, just using DET punya formula. Okay, DET formula SY over sigma prime. So you get your safety factor. Okay, safety factor 1.46. 1.46. Okay, for point B. Point B. Okay, ini pula MSST punya step. MSST. Okay, sigma X masuk value sigma X and tau XY tu. You will get sigma A is 196.9 megapascal. Sigma B is negative 2.5 megapascal. Okay, so sigma 1 is sigma A. Sigma 2, okay, is 0. Sigma 3 is negative 2.5. Okay, so this is related to yang Mohs circle tu lah. Okay, the principal stresses. Okay, so one of the principal stresses tu is 0. So consider sigma 2 will be 0, sigma 3 negative 2.5 ambil sigma B tu. Okay, safety factor for MSST. Okay, formula is SY divided by sigma 1 minus sigma 3. Okay, you get your 1.45. 1.45 safety factor. Okay, and then what happened is that dah dapat this point B, then we compare. Okay, compare with the A dengan B tadi lah. Okay, so since safety factor for part B ataupun point B is less than safety factor at point A. Okay, so that is the justification, okay, to select or to choose, okay, point B as the most critical point. Okay, for choosing, okay, the safety factor to be used, or safety factor, the critical point, okay, we have to select the one with the less value. Okay, so tadi at point A you have 2.8. Okay, both method 2.8. For point B you have 1.45 and 1.46. So lebih kurang, then okay, you should be able to tell, okay, you should be able to tell that this, the point B is the critical point, okay, because it's the safety factor is kecil je safety factor dia. Okay, so the one with high or big safety factor value will be more safe or safer. Okay, so that is one example. I mean, in relation to static failure theories, DET dan MSST. Okay, so next one I would like to tengok pula apa ni. Okay, the second example. Second example ni ditahan. Okay, tadi okay lah juga, boleh saya kira kan. Next is this question. Okay, saya akan share kemudian gambar ni. Haris Fauzi. Okay, so this is, okay, please, and the second exercise. Okay, second exercise. Okay, tengok soalan ni. Firdaus ada tak Firdaus? Firdaus. Firdaus dengar tak Firdaus? Farhan, Muhammad Nur Farhan. Syamir Amirul. Syamir. Cuma senyap je.
Ya, doktor.
Syamir minta baca sikit lah soalan. Dia tak nampak.
Nampak. Baca doktor.
Boleh tolong baca.
Okay. Alert W is supported by a three-cable system as shown in figure 1. The cable run along two pulleys F and D, which is attached to the solid wall by a round beam EF and CD, both of which are 30 mm diameter and 300 mm long. Ignore the mass of the cable and beam. All cables are the same size. The sizes of the pulleys at D and F can be ignored. Gravity is 9.81 ms. 2. The material properties is as follows. So for cable, the SUT is 180 megapascal. The SY is 130 megapascal. For the round shaft, the SUT is 300 megapascal and the SY is 280 megapascal.
Okay, terima kasih. Terima kasih Syamir. Aduh, yang lain semua tak ada mic rosak Okay, so tadi, what is in this question, if you see, this is one, type of question. Now, they are asking you to find the diameter of the shaft, diameter of the, no, given the diameter of the shaft, diameter of the, let me see. So, ada soalan tak ada. Given the diameter of the beam is 30 mm. Okay, so this is actually the problem, and it will actually require for us to design or select what is the appropriate size of the cable. Okay, size of the cable that can withstand the loading. Okay, sebab yalah. Okay, so this is one type of the designer, to find or to select what is the size of the cable to be used or safe to be used. Okay, then pakai the size of the cable which is very small, that cannot withstand the weight, the loading, then it will break and fail. Okay, so question number 1, find the tension in the cable, in the C cable. If the mass is 1000 kg, W is 1000 kg. Okay, in this question, okay, they provide with SUT and SY value. So if you are given, then senang sikit lah. And if not, you have to find from the table. Most probably they'll give you. Okay, because salah pula kan nak cari, kadang tak ada dia punya table tu, tapi one of the thing you have to know how to find lah from table tu. Okay. Okay, so okay, 1A, question 1A, this is just static punya problem. Okay, so ada 3 cable, so hopefully okay lah, refresh balik. Okay, okay, find the 3 cable, so summation of fx equal to 0, summation of fy equal to 0, should be able to solve for 1 and T2. Okay, so T2, okay, dapatkan first from summation of fx, you can get the relationship T2 with T3. And then, okay, and then solve fy, summation of fy equal to 0, you get to solve for T2 7118 and T3 8840 Newton. Okay, so that is first step. Dapatkan that 3, apa ni, the 3 tension lah apa. Okay, sekejap tengok apa lepas tu. The arrow. Nampak tak? Tak nampak. Okay, this is. Okay, so you get your. Okay, so that is the cable, the 3 cable. T2, okay, T2 7118 Newton. Okay, T1. T1 tu tadi yang daripada mass kan, 1000 kg times 98110 lah. Okay, so T3 8840. Okay, so that is the FBD for the cable. Okay, kemudian soalan B. Okay, this is the thing that we need to check. Okay, if all cables are of the same size, if all cables are the same size, use distortion energy theory to calculate the required size of the cable. Okay, what is the required size of the cable? Safety factor is given 2.25. Okay, so now we need to design lah to select what is the appropriate size of the cable based on kita punya loading. Okay, so from this free body diagram, we can tell T1 is the highest tension. Okay, T1 is the highest tension and therefore will be considered, okay, the critical point or the most critical lah. Okay, because the maximum load kan. Okay, so 9810. Okay, so T1, okay, sebab all the cable will be having the same kan, the same size. So mana yang paling besar kena sekarang ni? So 9810. So use that T1, calculate the sigma apa ni macam axial lah. Okay, along the cable tu. Okay, so using sigma average. Okay, sigma axial tu lah. Okay, is equal to P over A. So P use 9810. Okay, kemudian A is the pi d square over 4. Okay, that is the D, the diameter of the cable. So now we have that equation. Okay, with D. So 12,490.5 divided by D square. Okay, so that is the value for stress. Okay, kemudian kita cari apa sigma X. Okay, that will be the sigma X, sorry. Okay, so that is sigma X. So sigma X is equal to sigma average. Okay, dan tau XY tak ada, is 0. Okay, there's no torsion under shear stress, shear tu. Okay, so get the equivalent stress sigma prime. Okay, sigma prime is that the same value 12490.5 divided by D square. Okay, kemudian use the equation safety factor equal to SY over sigma prime. Okay, safety factor is 2.25. SY value 130 megapascal is given. Okay, so get your D value. D value, okay, 14.7. Okay. So dapatlah D kan. So D is 40.7. So T1 tu lah, kalau apa-apa T1 will fail first because is the highest stress, apa ni, tension dia tu. Okay, so D for the cable is 14.7. Kemudian okay, available cable size are 10.1, 11.8, 13.5, 14.4, 15.8 and 18 mm. What is your recommended cable size and why? Mana ni? What do you think? Iskandar Kasim. Sampai UTM dah. Iskandar,
Ya tuan.
what is your answer for 1C?
Ya tuan.
Apa Iskandar? What do you think? Anas ada tak?
Ada saya ada.
Anas rasa apa jawapan?
Saya rasa yang paling sesuai 14.4
Kenapa 14.4?
sebab dia paling dekat je.
Paling tepat, dekat. Okay. What about Azimi? Azimi dengar tak? Amin. Muhammad Amin.
Ya, doktor.
Mana satu Amin? 14.4 ke 15.8 sebenarnya?
Saya 15 kot.
15.8. Kenapa?
Sebab bila dia punya D besar, safety factor makin tinggi.
Saya rasa saya pun tukar saya 15.8.
15.8. Okay. Kenapa tukar tu?
Anas.
Anas. Kenapa Anas?
Sebab kalau rendah dia fail satisfactor dah.
Okay. So tengoklah, so dia punya principle, once you get dia punya minimum 14.7 kan, daripada calculation tadi tu 1B tu, okay, we get the minimum should be 14.7. Okay, so 14.7, okay, if you have the cable size available, the listed, okay, you cannot ambil yang kecil lagi lah. If you use 14.4, it will not be safe lah maknanya, okay, for the loading tu. So you have to select the higher and the dekat lah, paling dekat. Okay, so will be 15.8 mm. Okay, so that would be the best selection lah. Nak ambil 18 pun boleh juga, tapi kadang yalah, Okay, so we will probably tambahkan cost, tambahkan semua lah. Okay, or something like that. So in the design process, once you calculate, okay, get your equation, safety factor, and then get the answer. So then you will select based on that, okay, calculation. Okay, for the selection of the cable, okay, you should select the higher, okay, but with the closer lah, okay, the closest value. So 15.8 should be selected, okay, dan okay, because it is the minimum is 14.7. Okay, you cannot select kecil lagi lah, cannot go smaller than that. Okay, so that is for soalan apa 1C. Okay, next one is another soalan. Berapa ni jam? Okay, so ada soalan lain setakat ni?
Doktor,
Ya.
saya nak tanya sikit yang macam size kabel tu kan. Kan
Ya.
kena ambil besar sikit daripada 14.7.
Ya.
Kalau kita contoh lah, kalau kita ambil 18 tu adakah salah ataupun boleh di-consider lagi
Oh, untuk jawapan
untuk jawapan?
Depend lah, tapi K18 tu tak salah ha. Patutnya tak salah lah kan. Cuma you justify sebab jawapannya yang lah dalam answer tu 15.8 lah. Cuma patutnya 15.8 dan 18mm tu should be okay. Kan, cuma the best answer should be 15.8 dan tengoklah justification. Kalau saya, if you give 18mm should be okay jugalah sebenarnya. Okay. As long dia punya maknanya the cable should be bigger than 40.7 and then tapi kalau macam ni it ask you to select kata apa, dia bagi variable size kan. Tengoklah, tapi itulah patutnya boleh lah diterima tu 15.8 and 18. Probably the best is 15.8 but second 18. So tak tahu, kalau saya kira saya akan terima lagi lah. Okay, any other question? Okay, kita tengok the next one is on the second. Okay, this is from the same gambar tadi. Then continue with the tension T3 sebenarnya for TFB to T3. If tension TFB is equal to 9,000 Newton, find the maximum stress acting on the beam EF. Okay, so ini dia buat balik lah. So daripada puli tadi, daripada puli. Okay, daripada puli kita ni. Okay, your EF tu, kemudian okay, kemudian tension TFB. So the cable FB tu now is 9,000 Newton. Okay, so what is the maximum stress acting on the beam EF? Okay, so kan F tu is a pulley. So pulley FG equal to FB. Okay, so FG and FB now is 9,000 Newton. Itu yang FBD tadi tu. Okay, so this is the lebih clear. Okay, so this is the FBD. Okay, so 9,000 Newton naik atas dan 9,000 Newton turun bawah. Okay, because it is passing through the pulley. Okay, and then the support katakan at point E. Okay. and you need to solve for FBD dia. Okay, solving the FBD at point E, you get this value V equal to 2580.7, P 6308, and M 774210 Newton mm. Okay, ada soalan tak ni? Boleh tak? Okay, so that is for apa ni tadi? So now dia punya soalan dia P tu ialah 9000 Newton. You need to find the maximum stresses acting on the beam EF. Okay, the beam tu lah.
Doktor, yang kalau P tu boleh ke buat kan dia kan apa buat XY ada EX dengan EY.
Dekat mana?
Dekat FBD dia.
Dekat FBD dia.
Macam kalau rigid tu kan biasa kan ada moment dengan reaction X dengan Y kan.
Ya,
Tapi ini dia buat untuk compression je. Boleh ke?
Ini itulah, ini kamu tak perlu pun yang apa tu, ini just satu je boleh consider. Itu D ni lah. Kan tak perlu. Dia memang XY sebenarnya, this is XY. Cuma this is dia akan kamu guna this approach je lah, tak perlu nak kata negatif tadi. Akan ada dia punya ketika bending ni nanti akan ada dia punya positif dan negatif tu. Cuma get the one value first, compression, and that one will be consider for kalau dia punya stress distribution nanti kita akan consider jugalah for dia punya opposite tu. Okay, so nanti kalau kita tengok dia punya apa ni, dia punya bila ada positif dan negatif bending tu. Yang lain ada lagi soalan? Okay, untuk this, okay, this is tengok based on katakan forces tu, okay. So you see T apa 9000 Newton, you have vertical T, okay, kemudian ada T 9000 Newton yang turun bawah tu, okay, apa tu ada angle, so it's going to be, okay, kalau buat dia punya X component and Y component yang T bawah tu kan is going to be ada TX and TY. Okay, so TX tu akan counter by the P. Okay, that is the reason lah. Kita punya P tu ada kat situ and compression ataupun to the negative side tu kan. Maknanya compressing the point towards the point E tu. Okay, and that is the P, okay, 6308 Newton. Consider compression, okay, towards the point, towards the part component tu. So, and then use that to calculate the sigma axial tu lah. Sigma average equal to P over A. Give the negative sign because of the compression. Kemudian moment pun sama, moment. Okay, so just take the moment dan solve for M. Okay, you get your M 774 to 10. Kemudian get the sigma bending. Okay, sigma bending is apa tu? 292.1. Kita tengok sigma bending dia. Sigma bending is negative B. Negative 301. Sigma B tolak je tu. Sigma B 301 megapascal. Therefore the most critical will be sigma bending. Okay, so
Doktor,
yeah.
ni yang formula untuk stress bending ni 32 M over pi D kuasa 3 tu untuk semua bentuk
Ini untuk ini rasa D ni is the diameter apa ni of the round punya shaft lah.
Oh, untuk round punya shaft je lah.
Yes, round shaft. Sebab kalau tak round dia tak ada D tu diameter tu. Okay, so this is for round shaft. Dia punya cross sectional is round lah. Okay, bending moment, this is positive. Positive. Okay, so therefore the most critical will sigma x equal to minus bx minus average TO1. Okay, dia total up dia tapi negative b negative average. Negative b negative lah. Okay, so should be so ada negative lah. So negative. So sigma b minus dia tu. Okay, so the answer is 301. So sigma b minus sigma average. Okay, so sigma b mana sigma b? Sigma b bending tu is positive, negative lain. Okay, so it should be the most critical. So sigma b je, sigma b minus sigma average, you get your TO1 megapascal. Okay, so tau xy, tau yx, tau yx. Okay, tau yx is 0, tak ada. So that one is for what? Find the maximum stress. Okay, for kita punya compression. Compression tak tolak. Boleh just tambah. Okay, so that is for 2A, okay, the maximum stresses. Okay, so kemudian 2B, tengok 2B. Using distortion energy theory to find the safety factor. Okay, equivalent stress sigma prime is sigma x square plus 3 tau xy square. Okay, is going to be TO1 megapascal. TO1 megapascal. Okay, lepas ni just equation dah ada sigma x dan sigma average dan sigma b tu. Sigma x dan sigma b tu apa sigma x lah, sigma x kan. Sigma x tambah 2 tu. Tengok ni apa. Jawapan dia lepas tu. Oh. Okay, last kali inilah jawapan dia. Okay. Dapat tu just DET just SY divided by sigma prime kan. Okay, the beam will fail based on static failure theory. DET punya dia tak 0.93. 0.93. Okay. So okay, if kalau pakai this loading, okay, 9,000 Newton loading tu, okay, it will give you safety factor of 0.93. So 0.93, okay, it is less than the safety factor. Given safety factor, so the beam will fail. Okay, so that is the justification lah. Okay, based on failure apa DET, okay, this the beam EF cannot support the load. Okay, so that is for the answer. Okay, so ada soalan lain before we stop for a break sekejap. Okay ke Shantini? Nirsha. Shantini. Shantini okay ke? Ada soalan? So that is the types of question that they will ask to find the cable, kemudian relate with the safety factor. Safety factor. Kemudian you compare the safety factor between the point, safety factor between the parts. Okay. So if you have 2-3 parts, the one with the smallest safety factor, that is the one that will be used or considered to be used for your component. Okay. So that is the selection for the safety factor of the component. Okay, so we will stop for 10 minutes. Okay, stop sekejap for 10 minutes. We'll continue insyaAllah after 10 minutes. Okay, so take a break. Boleh makan kuih sikit. Dan in 10 minutes time we will come back. Okay, so thank you.
Dah doktor,
Ya.
boleh share tak semua soalan ni doktor?
Okay, nanti kejap lagi nanti saya akan share.
Okay, thank you doktor.
Sebelum ni dah masuk itu. Pernah masuk kan?
Ada masuk ada.
Ada eh? Okey, tak apa. Seremban kat mana? Seremban apa?
Pantai. Jalan Jelebu.
Jalan Jelebu?
Ha,
Oh,
pantai.
santai.
Tak ada laut.
Saya pun ada keluarga kat Jelebu. Apa Jelebu? Kampung. Ya. Okey, baik. Okey, just to ada berapa nama dalam sini saya ni yang tengok kalau kawan-kawan kamu ada kenal Nurhanani ada 2 orang budak perempuan ni tak masuk. Nur Sarah dengan Nurul Najihah, kenal tak? Kalau kenal please.
Kenal tapi tak tanya pula.
Saya tanya dia orang dah masuk section lain ke apa ni, sebab nama dalam list saya ada ni tapi.
Okay.
Okay, so itu ada Sarah dengan Najihah. Kemudian yang budak lelaki siapa lagi ni? Ikram ada kah? Saya Ikram. Syahir. Nanti saya check balik. Okay, so tengok this is another exercise. Nanti kita dah tengok tapi the part FBD dia lah. Okay, just to continue. Okay, so kita akan tengok balik this example. Okay, this is another type of component lah. Okay, ada bearing, ada shaft. Nanti yang ni yang pakai apa ni, kita akan pakai top view dan front view tu. Okay, to find dia punya FBD dan juga forces reaction dia. Okay, so kita tengok sikit. Okay, figure Q3 show a shaft to transmit power from pulley A to pulley B. Assume the tension of the belt at B is T2 sama dengan 0.15 T1. Okay, so yang ni kita dah tengok sebelum ni. So dengan pulley B tu is given diameter, sekejap. Besar sikit. Diameter 150 mm. Okay, kemudian the shaft is given IC 1040 HR. Based on this information, okay, draw the shear moment and torsion of shaft OABC. Okay, so first step, okay, we boleh pakai summation of torque. Okay, so remember this will involve equilibrium. Okay, kita akan consider as the condition, equilibrium condition. So you can use the, for example, total summation of the torque is equal to 0. So TA plus TB equal to 0. Okay, TA tu 1200 minus or plus 200. Apa ni, divide 1200 minus 200. Okay, this is to find the torque. Okay, so torque dia ialah the apa ni, the force times the distance from apa ni, radius of the pulley. So 1200 minus 200 divide by 200 divide by 2. Okay, that is for pulley A. Okay, pulley A tu ada diameter is 200, and then pulley B 150 minus 150 minus divide by 2. Okay, so T1 minus 0.15 T1. Okay, get the T1 value. Okay, and remember untuk this kind of problem, the pulley, okay, the torque, okay, the torque ataupun the maximum torque, okay, will be considered to be between point A and point B. Okay, between pulley A and pulley B lah. Okay, so from point A to point B, the shaft is subjected to the torque with the value of boleh kira lah sebenarnya. You can just take one of the pulley tu dan kira torque dia. Okay, they will give you the same value. 1200 minus 200 times 100, you get 100,000 Newton millimeter. Okay, kalau ambil yang dekat yang pulley B pun nanti they'll give you the same value. Okay, because mana ni? Okay, so they'll give you, okay, so torque punya apa ni, torque punya, okay, the torque punya graph tu, okay, so torque punya graph will be just like that. Okay, so daripada O pergi A, dekat pulley A tu, so it's going to give you the 100,000 Newton millimeter. So dia akan up, dan that value 100 tu so akan constant. Pergi dekat B dan balik. So that is the way. Okay, so remember dia punya pattern lah ataupun dia punya graph of torque. This is for graph of the torque. Saya snap lah nanti boleh kamu refer. Okay. Kemudian saya nampak apa tadi? Okay, the next one is on the okay. The next one is on the moment dan torsion diagram. Moment shear dan moment diagram. Ini biasa je lah. Okay, so this kind of problem. So okay, kita dah tengok dah itu juga. Okay, so from the plane XY. Plane XY ni is, XY is the front view. Okay, so XY from the front view, okay, you can just ambil ke atas at point A, you will have the 1200 plus 200, so become 1400 Newton. Okay, at point A. At point B tak ada. Point B the pulley tu, oh, from this view, okay, Kemudian you have your support at the bearing lah. Okay, so apa? Okay, ini boleh support at the bearing O, boleh pointing downward. Support at bearing C pun boleh pointing downward. So just calculate taking moment dan juga taking moment, solve for FC ataupun RC, and then summation of vertical. You can solve for apa tu 891 tu FO FO. Sorry. Itu FA pula kan. Juga. FO tu So that is for dapat FC 509. FO dekat O tu ialah 891. So untuk shear, so that is the shear diagram. So turun bawah 891, and then horizontal 891, nanti point A, naik atas balik 891, lepas tu naik lagi 509. So that is the shear. And then calculate moment at point A. Moment at point A, draw the moment diagram. So just ambil lah. So 891 times the distance OA. Distance OA berapa? 200. So dapat that MOA. Dia MGA, dia tulis situ MGA. Nampak? So that moment diagram. Kemudian moment at point B pun boleh calculate. Just 509 times the distance BC 150. Dapatlah value 76350. MZA dekat situ MZA dan MZB. That is for that. From the front view, from the top view. Top view yang belah kanan ni. Top view. So from top view dekat point B, we have the tension turun bawah. Tadi kita dapat T1 is 1569. So dapatkan total T itu is 1804. 1804 Newton. So dekat point O dan point C tu boleh buat naik atas lah. The support. Just to counter for force T tu kan, tension. Dapatkan moment. Moment, solve for FC and then solve for FO. So you get FO 492 Newton. 492 Newton. And then draw your shear diagram. 492 all the way from O to B. Dekat B baru turun balik. 1804 turun ke bawah. 492 tambah lagi 1312. You get your 1312 sampai dekat daripada B ke C. From the C back to dia punya original apa tengah-tengah tu. So and then calculate, get your moment diagram. Moment diagram. Maximum dekat B. Get the MZB. Boleh pakai 1312 times 150. You can get your value for MZB. MZB lah. Tak apa. Boleh. MYA pun dapatkan MYA value 492 times 200. So that is the two value yang penting dekat point A, dekat point B. We would like to get the moment at the 2 point. And then go calculate the total moment. Total moment at point A. MZA square plus MZB square root. Kemudian dekat MGB, MZA, MYA. Kau tengok Kemudian yang kat point B. Okay, point B MZB square plus M YB square. Okay, so square root, you get the total moment. Okay, ada dua MA dan MB tu. Okay, you have MA 2.03 10 to the power of 5. Kemudian MB is 2.111 E5. Okay. Kemudian okay, determine the most critical point. So from the two MA MB tu, you need to get the higher value, which is point B. Okay, so point B 2.11 E5 and T is 100,000. Okay, so okay, so ini yang kita dah tengok tu kan. Okay, kemudian okay, next one, calculate the safety factor. Calculate the shaft safety factor. Okay, calculate the diameter. So calculate the diameter of the shaft if the safety factor of 4 is set against static failure using distortion energy theorem. Okay. Dia tak clear tak? Clear. Sabar. Boleh clear lagi tak? Okay, cantik sikit. Okay, so calculate the diameter of the shaft if safety factor of 4 is set against static failure using distortion energy. Okay, so okay, use the equation 32m pi d cube. Okay, m is the 2.115 15 lah. Okay, sorry, dia tersilap 11. Oh sorry, dia dah clear. Sorry. Okay, so that is the equation. Okay, 32m pi d over pi d cube. Okay, to that for sigma. Kemudian for the torque 16t. Okay, 16t over pi d cube. Okay, dapatkan the 2 d from the DET. Sekejap, kita tengok mana DET. Okay. Okay, this is the equation for this sigma prime. Okay, sigma prime. Sometimes we need to sigma e. Okay, it's for sigma prime equal to sigma square plus 3 tau square. Okay, sigma. Okay lah, boleh. Okay, so you dapatkan that sigma prime ni. So sigma e, dia tulis sigma e tu e for equivalent. Okay, sigma equivalent atau sigma prime lah. Okay, so your equation will be in terms of d cube. Okay, kemudian sy value, okay, from the material given. Okay, get the sy value SY is 414 megapascal. Kemudian you are given safety factor of 4. Safety factor of 4. Okay, so you can get or calculate your D value. Okay, so the shaft, diameter of the shaft with the safety factor of 4, okay, using distortion energy theory is 28.2. 28.2. So 28.2, so probably 29. Okay, so macam tu lah lebih kurang dia punya. So your shaft should be probably 29 mm. Okay, nak dapat 28.2. Okay, so that is for SET. Okay, this one ada note the case of maximum shear stress theory. You have to calculate principal stress based on Morse circle equation. Convert them to sigma 1, sigma 2 and sigma t. Each one of them must equal to 0. Solve for D using SY, SS. Okay, ni untuk MSST. Okay. Sigma 1, apa tu yang SY, SY over sigma 1 minus sigma t or sigma t minus sigma 1 lah. Okay, so that is for. Okay, this one. If the length of, tengok yang last kali soalan last. If the length of OA and BC is reduced by 20 mm, do you require to have smaller or larger shaft diameter? Justify your answer using only engineering judgment without any calculation. Okay. What do you think? Apa agak-agak? Amirul Shah? Apa jawapan tu yang last tu? What is your opinion? Amirul Shah dengar ke? Ke dah mana ke kamu? Oi, mana kamu? Fakrul Izwan, ada tak Fakrul Izwan? Oi, Fakrul Muhammad Fakrul Izwan. Wah, ada dua. Oh, satu Fairul. Fakrul Izwan ada tak Fakrul? Pun tak ada juga. Fairul Izwan. Apa lagi ada? Haris. Oi, semua dah balik ke? Oh, semua dah banyak dah left. Yang 19 je. Apa yang tinggal ni? Dah penat lah. Azimi, mana Azimi? Pun tak ada juga. Ahmad Lokman.
Ya, Doktor.
Lokman tengok yang jawapan yang last tu apa kakak?
Yang mana, Doktor? Yang
Yang 4
last.
tu. If the length of OA and BC is reduced by 20 mm. Nampak?
Okey. Gambar tadi yang mana, Sir?
Gambar dia gambar yang ni gambar ni. Ni Syah ni. So dia reduce OA tu reduce dan BC tu reduce. Ni gambar dia, gambar shaft tu. Maknanya pakai shaft yang lebih apa pendek lah. Apa jadi pada
Nanti dia effect dekat movement dia kan.
moment dia, betul?
Apa dia tanya tadi Sir? Tanya apa dia soalan?
Tanya soalan dia.
Kalau dia
Do you require to have smaller or larger shaft? Pakai besar lagi ke diameter shaft tu atau kecil lagi? Boleh pakai kecil lagi?
untuk dapat safety factor yang sama ke apa Sir?
Untuk katakan safety factor yang sama.
Yang lagi besar yang lagi besar Sir kan? Yang lagi ni. Kalau dia reduce.
Length of it is reduced. Do you require? Kamu perlukan, do you have require a smaller or larger shaft? Maknanya kalau benda tu lebih pendek, kamu perlukan besar ke?
Besar kan?
Uh,
Sebab dia punya diameter dia akan lagi besar Sir.
The length. Do you require to have small size? Based on soalan ni, if the length of OA and BC is reduced by 20 mm, do you require to have smaller or larger shaft diameter? Justify your answer using. Okay, just untuk ni. Kalau dia reduce je, kalau kita reduce je dia punya size tu, bukan dia punya pendek tu, apa panjang dia tu, kan? Apa dia punya requirement
size kan?
Untuk
shaft tu kan?
Untuk shaft tu.
So kena lagi besar Sir kan?
Dia lagi besar. Dia patutnya boleh pakai lagi kecil maksud dia tu. Sebab dia punya moment dah makin kecil.
So dia
ni you can use smaller shaft. Okay. Because the moment yang dia akan produce is going to be makin kecil. Okay. So if the length of OA ataupun NBC is reduced by 20 mm, kan? Misalnya, do you require to have smaller or larger shaft diameter? Okay, maknanya kalau dia makin pendek benda tu, your shaft tu, then you can use small shaft. Okay, maknanya size shaft tu kita boleh pakai lebih kecil lah. Okay, because the moment that dia punya shaft tu create is going to be makin kecil. So, kita boleh pakai smaller shaft size lah. Because of the moment is going to be smaller. Itu jawapan dia lah sebenarnya. Faham tak? Faham tak?
Okay, okay.
Because all this analysis kita nak tengok kan dia punya maximum loading tu. Kalau load tu besar, maknanya shaft tu kena lagi besar lah. Tapi if the loading is makin kecil kan, dan moment is depending on the distance kan, dia akan force time the distance tu. So once you reduce the length kan, it's going to, jadi you punya structure atau komponen tu akan makin kurang sikit lah dia punya load dia tu. Okay, for moment tu makin kurang, so you can use smaller shaft. Okay, so that is the justification lah. Okay, so if the length of OA and BC is reduced by 20 mm, you can use smaller shaft because the moment is going to be smaller. Okay, so that is the idea. Dan what is the safety factor? Dia tak ada safety factor dah. Okay, so that is for question. Okay, next example, exercise. Okay, last exercise lah for today. Okay, tengok soalan ni. Okay, you are given a beam. A beam is fixed to the concrete wall as shown in figure 1. Dimension are in mm. Okay. Section S1 tu dekat pangkal tu, dekat wall is 12 times 12 mm square. S is 8 times 8 meter square mm square. 2 holes H1 are drilled at A and B, and 1 hole H2 at C. Given L1, okay, tengok yang atas belah tu, dia punya top view. L1 is given 14 mm. L2 is given 8.87.37. L2 ke atas. Panjang, the length of the apa ni, AD. Okay. Given the force PX is 800 Newton. Static stress concentration is ignored. Okay, find the stress acting at hole A by determining the force and moment acting at A, the moment of area I and the cross-sectional area of A, the axial and bending stress at A, principal stresses. Okay, ni semua find kat A dulu. Okay, so ada beam, kemudian dia letak ada the drill hole dekat situ. What will happen to your safety factor? Tak safety, tak ada lagi belum. Sorry. Okay, find the stress. Cari stress dulu, stress. Stress bila ada lubang, ada hole, macam mana nak cari. Okay, kita okey, tengok dia ni tak mana dia punya. Okay, so this is the solution lah sebenarnya, solution dia. Tengok. PX is 800 Newton. Okay, itu given, PX 800 Newton. Kemudian kita moment ni kat mana ni? Moment PX kali dengan L1 plus 6 mm. Okay, moment dia. Hole A. Okay, PX tu akan create moment, okay, ataupun bending moment lah. Okay, so dia punya moment is going to be PX kali L1 plus 6. Okay, itu daripada yang atas ni lah. Tengok dia punya apa ni. Tambah dia balik. Okay, tengok gambar dia tu. So, okay, moment PX kali dengan L1 tu 14 tambah dengan 12 bahagi 2. Okay, so that is the moment, bending moment. Okay. So dia, itulah. Distance between lubang A tu 6 tambah dengan L1. So that create the bending ya. Bending moment. Dia tarik tak. Okay, so that is for M1. Kemudian nak saya share. Okay, so that moment M dapat 16 Newton, 16.00 Newton. Kemudian okay, ni yang kadang yalah dia ada hole kan punya problem kan. So kamu tengok macam mana dia punya approach, okay, to solve the problem. So cross section area, katakan the 8x8 okay, 8x8. The B is 8. Okay. So the beam tu ialah 8x8. S1, S2, 8x8. So that is the beam. 8x8. Okay, the base and height. Okay, D1. What is D1? D1 is the lubang diameter tu. Diameter of the hole is 5 mm. Kemudian Y1. Y1 is 0.5 B. Okay, 0.5 B. B is 8. Okay, Y1 ni ialah is your apa ni distance from the neutral axis. Okay, dia punya Y1 0.5 B. Okay, yang sebenarnya daripada moment punya apa ni bending stress MY divided by I tu. MY divided by I. Okay, dekat bending stress. So dia pakai MY divided by I. Okay, so area A1. A1 tu tengok B minus D1. Okay, dia ambil cross sectional area. B minus D1. D1 tu the diameter. Diameter of the hole tu lah. Times the height. Okay, dapat cross sectional area A1. Kemudian calculation for I. Okay, the second moment of area. I1 HB cosine 3 minus HD1 cosine 3 divided by 12.
Doktor.
Ya.
Macam mana dia dapat B sama dengan 8 tu
B sama dengan 8.
Kat gambar rajah tu.
Okay. Okay, B sama dengan 8 dengan H sama dengan 8 tu ialah the dimension of the shaft tu, shaft S2 dia panggil, kan yang tengah-tengah punya shaft yang panjang tu. Dia punya dimension is 8 times 8. That is the apa ni? The dimension for kita punya shaft. Okay, so tu yang pakai 8x8 tu lah. Okay. So for the apa ni, for shaft yang S2 shaft. Kemudian okay, ada lagi soalan. Itu yang B dengan H tu lah, 8x8 tu. Okay, yang lain okay Y1, okay Y1 tu dia kira dia untuk bending kan. Okay, daripada yang garisan tengah tu lah, apa tu, yang garisan merah putus-putus tu. Okay, so that will be your Y1. Y1 apa, daripada pada hujung lah, maknanya from atas apa dia punya end of the shaft tu lah, end of the maximum lah, maximum untuk dia punya bending stress tu. Kan bending stress kan kita ada dia punya maximum point dekat luar kan. Outer apa ni? Outer part. Okay, dekat neutral axis is 0. So okay, the distance is B tu divide by 2 lah. So dapatlah half tu 0.5 B tu. Okay. Okay, so sigma A1 is just kita punya PX divide by A1. Okay, it is the apa tu? The axial punya force. Okay, so PX tu along apa PX 800 A1 tu okay, dah ada dah. We have calculated 2.4 times 10 power minus 5. Okay, that is for axial loading. Okay, kemudian for bending loading, okay, bending stress my divided by I. Okay, ni pakai my divided by I tu lah. Kita pakai 32 tadi kan, let's say 32M tu. So the same thing. So, okay, and then proceed bending stress dia dapat 248.06. 248.06. Okay, this is the part yang kena berhati-hati ataupun slowly tengok. Okay. So since bending, kalau recall bending kan, bending tu biasanya you have tension dan compression. Okay, dia punya katakan half part of the neutral axis tu akan experience tension. Okay, dan another half part of the neutral axis tu will experience compression. Okay, so for sigma extension, okay, we can consider to use sigma B1 minus sigma A1. Sigma A1 tadi apa? Axial kan? Axial. Sigma B1, the tension punya stress, dia katakan to the positive x direction, and then kita punya axial is opposite. So sigma B1 minus sigma A1. Okay, sigma apa ni? Sigma B1 is 248 minus 33. Okay, 248 minus 33. Dapatlah 214.73 tu. Okay, so that is for sigma x tension. Okay, sigma x lah sebenarnya, sigma x tension untuk tension. Kemudian using for calculate dia punya sigma apa ni, sigma A1. Sigma A1 ni sigma principal stress lah kan. Okay, sigma A1 equal to sigma xt divided by 2 tambah sigma xt over 2 square. Okay, so boleh pakai equation ni. Okay, dan dapat 214.73 je, sama je. 214.73. Okay. Dan sigma A2 apa ni? Sigma 2 lah sebenarnya, principal. Okay, is 0. Okay, tolak pula. Okay, so that is for tension part. Kemudian, okay, untuk compression. Kemudian, okay, consider for compression. Okay, compression pula ambil sigma B1 minus bending tu. Okay, so remember bending tu dia ada dua sebenarnya kan. Satu dia akan pergi positive part, positif, satu yang negatif. Tapi dia punya value tu sama je. Okay, so ambil minus B1 minus A1 now. Okay, so dapat berapa? Minus tadi 244 minus 33. Minus 248 minus 33. Dapatlah minus 281. Okay, minus 281.4. Kemudian you have your, okay, dapatkan principal stress dia. Sigma A3 is 0. Okay, sigma A4 is minus 281.4. Okay, tolak. Okay, so that is sigma tension dan sigma compression. Okay, so that is kemudian is what? Kemudian sigma XC. Okay, ada soalan? Itu untuk sigma untuk buka point A tau, hole A tu. Hole A. Okay, sekarang now I would like you to try to solve for second year. Okay, find the stress acting at hole B. At hole B. At hole C, sorry. B tu sama aja. Cuma ialah distance kan. Distance tu sama. BAB. Okay. So sekarang ni you have about 40 minutes lah. Okay, untuk find the stress acting at hole C. Find the force and moment acting at C, the moment of area and cross-sectional area A, the axial and bending stress at C, dan principal stress at C. Okay, so sekarang ni 10, 11. Okay, I would like you to try and submit by 11 lah. Ataupun 11:10 lah, 11:10. So, okay, give it a try. Saya akan we will allow you to leave the session and give it a try. Dan nanti saya akan sharekan lah dia punya kemudian. Okay. So, any question before we end the session? Okay, you need to complete the exercise. Okay, exercise. Find the stress acting at hole C. Okay, on this problem. Okay, saya akan sharekan, dah share tadi kan. Okay, and you need to submit by 11:10. Okay, submit dekat, let me see, my email, I will send the email. Okay, so ada soalan tak sebelum kita tunggu? Okay, nanti saya sharekan yang bahagian A tadi, code A tadi pun 4. Okay, Tanesh ada ke?
Mental focuses. We have different frequencies.
Can you repeat?
And we have
Yes, Doctor.
frequencies.
Okay. Ada soalan tadi tu. Siapa tu? Syantini ke siapa? Okay, I will share the apa tadi tu solution for A. Okay, and then you give it a try on whole C ni. Okay, so okay, you may leave the session and try the soalan. Okay, thank you very much for joining the session.
Doktor,
Ya,
Sarah dengan Jiha tukar section.
okay, baik, terima kasih.
Okay.
Stop sharing. Okay. Okay, so saya dah share contoh untuk bahagian whole A tadi. So give it a try on whole C dan submit to my email. Okay, saya dah share dekat group. Okay, so thank you very much. We'll insyaAllah see you later. Terima kasih.
Thank you, Doktor. Thank you, Doktor.
Thank you, Doktor. Assalamualaikum.
Okay.